So we're still working on factoring polynomials. We last learned difference of squares. Let's move on to the next process, which is very similar to that. It's actually the sum or difference of cubes. Now, when we did difference of squares, one of the key words are difference here. So when we do these, we note that our operation in between our two terms is subtraction. Now, when we're doing cubes, it can actually be addition or subtraction. Both of those will factor. Again, back to difference of squares. Notice that there is a formula to it over here, but notice we didn't actually factor any of our examples by using the formula. So you can memorize this formula, but I think it's actually easier to do it without, since we already know the trinomial process. But back to the cubes, there's a formula that goes with this, and unfortunately, I don't think that we can do the process of factoring these without just memorizing and using the formula. So the first thing I'm going to do is give you the formula here, and then we'll use this formula in our two examples down there. Okay, the format of this is something cubed plus something cubed or something cubed minus something cubed. The formula starts with a short set of parentheses. I'm going to put two terms in here, a binomial, and I'm going to multiply that by a long set of parentheses. I'm going to put three terms in here, or a trinomial. And all cubes will end up this way. In your short parentheses, you're going to take exactly what you see here, but without the cubes, and that goes in your first set of parentheses, a plus b in this example. Now I need to figure out what goes in the long set of parentheses. So in my first term, I'm going to put my first guy, which is a, and I'm going to square it. And the reason that I'm going to put a squared there is because I need to multiply my first two terms, a times a squared, to give me my first term over here. So a squared goes in your first place there. Now, in my last guy here, I'm going to take my last term of b, and I'm going to square it. And for the same reason, because if I multiply b times b squared, that needs to give me my last term of b cubed. So the only thing left I have to figure out is the middle piece here. And that comes from multiplying our two terms. So I have a times b. Now the last thing we need to figure out is our signs. And there's a pattern that goes with it. If your original example is addition, then your first set of parentheses should be addition. And your following sign should be an opposite sign. So if it's addition here, it should be plus there. Now back here, it doesn't matter. This sign back here will always be addition. Okay, so let's set this up again with the same thing down here, but this is an a cubed minus b cubed. So in my first set of parentheses, I have exactly what I see without the cubes. In my first place, I take my first term of a and I square it. In my last place, I take my last term of b and I square it. In the middle, I multiply a times b, and now my signs. So this one was minus, this one is minus, this one is opposite of those signs, addition, and this last sign here is addition. So this is how my formula works out. So if I can set something up like this here, then I'm just going to plug it in my formula from there. So my suggestion on these examples is to get it in this format so the rest of it is really easy to go with. So moving to example 1, doing the same checklist that we always do. Do I have any common factors throughout? No. Do I have two terms, and can they be written as something cubed plus something cubed? If they can, then they are going to fill into my formula nicely. If they cannot, then I can't factor it using this process. My first one's pretty easy. It's just going to be x because I know that x cubed, of course, is the same thing as x cubed. Back here, I have to figure out something times itself 3 times to give me 125, and that is 5. 5 times 5 is 25, times another 5 is 125. So now I have this filled into my format that I want it to be in up here. Something cubed, in this instance, plus something cubed. So x is going to go every place that I saw an A, and 5 is going to go every place that I see a B. So let me go ahead and set up my formula. Short parentheses and long parentheses. In my short parentheses, I take exactly what I have with the exception of the cubes, and that's what I put there, x plus 5. In my long parentheses, I need something times x to give me x cubed, and so that gives me x squared. In my last place, I need something times 5 to give me 5 cubed, and so that will be 5 squared. And again, I'm just following the back piece of my formula up here. But if this can be simplified, then I should be simplifying it. So I do not want to leave it as 5 squared. I want to write out what 5 squared is, and that is, in fact, 25. So that's what I'm going to put there. In the middle, I just multiply my two terms. X times 5, or the simplest way of writing that is 5x. Now I only have to worry about my signs. So if my middle sign's addition, then this should be addition, and this sign will always be opposite. So that's going to be subtraction, and this sign back here will always be addition. So I have my final answer. Now, just because we factored it one way doesn't mean that I cannot continue to factor it another way. So double check this first set of parentheses. I have two terms there, but the only way I can factor two terms is if they're a difference of squares, which doesn't match, or if they're a sum or difference of cubes, which doesn't match. In my second set of parentheses, I have a trinomial. So I might be able to factor this farther. But let me give you a hint. This second set of parentheses after you do the cube formula will always resemble a trinomial, but it will never factor as a trinomial. So don't waste your time in trying to factor it farther, because I just told you that it never will. So we finally have our answer to example 1. Let's move over to example 2, and I suggest that you try this one on your own. All right, first question, do I have any common factors throughout? And I do not. Since we're working examples of factoring by cubes, let's make sure that these are cubes. So I need something cubed, in this instance, minus something cubed. In my first parentheses, a 2 cubed will give me 8, and an m squared cubed will give me 6. If you remember back to your exponent properties, you would multiply these two exponents, and 2 times 3 gives me 6. So that's how I came up with m squared. In my back parentheses, I'm going to use 3 because 3 cubed gives me 27, and then n. So n cubed gives me n cubed. Now up to my formula up here, any place that I see an A, I'm going to plug in 2m squared. And any place that I see a B, I'm going to plug in 3n. And I have to plug in these whole guys for all of A and B. So set up my short set of parentheses and my long set of parentheses. In my short set of parentheses, I use exactly what I see without the cubes. So that is 2m squared minus 3n. In my long set of parentheses, I take my first term of 2m squared and I square it. So I want to simplify that before I put it in my answer down here. 2 squared gives me 4, and m squared squared gives me m to the 4th. So don't forget that you have to square all of your terms. So down here, this gives me 4m to the 4th. In my last place, I take my last term of 3n and I square it. So 3 squared gives me 9 and n squared gives me n squared. So that's what goes here. And in the middle, I multiply my two terms. So 2 times 3 gives me 6 and m squared n. Looks like I didn't leave myself enough room there, so I'm squishing it in. All right, now my signs. This is a negative, so that means this will be a positive here, and my last one is always a positive there. So this gives me my final answer of 2m squared minus 3n. I cannot factor this farther because this one never factors farther. It will never factor the trinomial. And this one has two terms, but it doesn't fit my difference of squares or another version of sum and difference of cubes. Now let me go back and talk about something here. I've given you these formulas up here, but I never specified where these formulas actually came from. So the way I'm going to clarify where these formulas came from is we're actually going to check these examples down here. So we have our answers here, but we did not check these answers to make sure they worked out to give us the original problem here. So let's go ahead and do this at this time. Now this is not any special form of multiplying out. I can't distribute, I can't FOIL. So I'm just going to make sure every term in my first polynomial gets multiplied by every term in my second polynomial. So in example 1, let me take my x and distribute it through. That gives me x times x squared, or x cubed, x times negative 5x and negative 5x squared, and x times 25, which gives me 25x. Then let me distribute my 5 through. So 5 times x squared gives me 5x squared. 5 times negative 5 gives me a negative 25x. And 5 times 25 gives me a 125. So I had 2 terms times 3 terms, which should give me 6 terms, and I do. Now, if I were to simplify this, notice what happens. I have a negative 5x squared, and that cancels with a positive 5x squared. And I have a positive 25x, which cancels with a negative 25x. So all I have left is my first piece of x cubed plus my last piece of 125. And that confirms I'm back to my original answer. So the reason that these formulas are this way is because all of these middle terms here end up canceling out. So that is why this formula works out the way that it does. I'm going to leave example 2 to you to check and make sure that all of those cancel out, leaving you back with the original problem here. And so we have completely finished how to work forwards and backwards the sum and difference of cubes.